Welcome, this is Dr. Plague, and in my last video on making a flash memory programmer, which was part 3, I gave my viewers an assignment to create their own dump command. I also mentioned that I would reveal the code for my dump command in a later video. Well, that time has now come. You may have seen me use the dump command in some of my recent videos on homemade CPUs, so I figure it's time to show the code in case anyone had trouble designing their own. So first, let's take a look at how the command works. Let's say I want to view the first 32 bytes of data in the flash memory chip. I can enter the letter D for dump, then follow that with the number 32. We can see the first 13 bytes are programmed, and the rest are all FFs. The number on the left on each line is the hexadecimal address for the first byte following it. Now, if I want to just print out the first 13 bytes, which are the only bytes currently programmed, then I could enter D13. But first I would need to set the address back to 0. If I don't set the address back to 0, then it will continue from where it left off, like this. We can see the address is 20 hex. So I can just enter A0 to set the address back to 0, and then I can dump the first 13 bytes. Notice that the output is formatted with up to 16 bytes per row, with an extra separation between every 8 bytes. So that's the goal that I'm looking for. I also created another bonus command to customize the formatting of the output. Although this command is not necessary, I will be using it in some future videos, so I've decided to share the code with you. The command starts with the letter F, which stands for formatted dump, and then it is followed with the number of rows or lines that we want printed out, then a colon followed by the number of bytes per line. So, let's say, for example, that we have a number of records stored in the flash chip that contain 19 bytes each. And let's say that we want to print out 12 records of 19 bytes each. Let's first go back to address 0. Now I can enter F12:19 to print out the 12 records. And I could print out 12 more, continuing from where we left off. Now let's go back to address 0. For another example, let's say we have a processor that contains instructions that are 3 bytes each, 1 byte for the opcode and 2 bytes for the operand. Now, if I want to print out the first 10 instructions, I could just enter F10:3. And now each line would contain 1 instruction. So those are the 2 dump commands that I'm interested in implementing. And here's the updated help command list with the dump and formatted dump instructions added. Let's look at the code. Here's one way that we could implement the dump command. And I'll also show another way to write the code, since there are many ways you could code this up. This version of the function is named dump. So, just like in either my setCurrentAddress function or my writeByte function, I start out defining a variable to hold the parameter, and I've named it param. Then, with the if-else statement, I scan in the number of bytes to dump out and print an error message if that failed. Next, within the body of the if statement, I've created a for loop that will continue while we still have data to print out and the current address is within the size of the flash chip. First, I print out the current address. Then, I have another for loop to print out up to 8 bytes with 1 space after each one. Notice that I decrement the parameter variable for each byte that is printed. Then, I print out an extra couple of spaces before heading to another for loop to print out up to 8 more bytes. And finally, I print out a new line character. Notice that there are 3 for loops in this version of the code. And that's fine, but we could do this with just 1 loop. Here's another version to do basically the same thing. This one is named dump2 and uses the same method to scan in the number of bytes to dump out. I've defined a new count variable for the for loop right here, and it is incremented each time through the loop. I also decrement the parameter variable each time through the loop, since only 1 byte is now printed during each iteration of the loop. And of course, we loop until there are no more bytes to dump out, or we get to the end of the memory space. The count variable will keep track of which of the 16 bytes per line we're currently looking to print. If we're on the first byte, then I first print out the address. After that, I print out the current byte with a space. If we're on the 8th byte, then I print 2 extra spaces. And once we're past the 15th byte, or if this is the last byte, then I print a new line character and reset the count to 0. Now, obviously, there are other ways you could implement the dump command, but these are just 2 examples that you could use. To show you that each one works, I've altered the code so a lowercase d will call the first dump function, and an uppercase d will call the second dump function. If we look at the second dump function, we can see that the address has a semicolon after it, whereas the first dump function had a colon. So let's go back to TerraTerm and test them both out. I'll dump 27 bytes with each version. You can see that they look identical except the first version has a colon, and the second version has a semicolon. Okay, let's go back to the code, and I'll show you how I set it up to distinguish the difference between lower and uppercase. The only thing I really changed with the code was to put the toUpper command in the switch right here. Previously, it was before the switch statement, and the uppercase result was stored in the command variable. Now the command variable is left unaltered, so I can use it in the case body right here on the lines with the temporary code comments. Also, down here, you can see the formatted dump case calling a function named formatted dump. Let's go take a look at that function now. So, I have a variable for the parameter, number of rows, and number of columns. Then, I scan in the number of rows and the number of columns after verifying there is a colon separating them. Before dumping the data, I print out the header for the following lines. And then, similar to the first dump function, I have 2 for loops for printing out the data. The outer for loop is for the rows, and the inner for loop is for the columns. Before each row is printed out, I print out a decimal number indicating which row we are on, and I print a hexadecimal value for the address. Then, I print out each byte within the inner for loop, and follow each line with a new line character. And, of course, to complete the changes, we need to add the prototypes to the header file right here. You could add additional formatting parameters. You could print out the characters that the data represents, along with the hexadecimal values, or whatever you want. Make it your own. Well, that's all I wanted to show in this video. I'll come back to the Flash programmer in the future and finish it off. Thanks for watching, and I'll see you next time, right here on Dr. Play.